Right now I want to work through a problem that's about as bad as it gets and kind of show you how I want you thinking about working problems involving exponents. Sometimes they'll only have positive exponents, but this one has both positive and negative ones. And I want you just to realize that no matter how bad the problem is, it's always going to boil down to about 4 steps, 4 basic things that you're going to do. All right, the first thing we're going to do is get rid of the parentheses by applying that power of a product rule. So do you see how the parentheses are telling you that 7u squared v to the 4th is all the base being applied to the negative 4th power? And so all of that's being raised to the negative 4th power. That negative 4 applies to each of these, to the 7, the u to the 2nd, and the v to the 4th, okay? All right, so what you're going to do in your first step is you're going to raise each of those things to the negative 4th power. So you're going to have 7 raised to the negative 4th power. And then this next spot is really going to be u to the 2nd, but it's going to be raised to the negative 4th power. This step I normally don't write. Once you understand it, you don't write this step, but I'm writing it so you'll see something. And then that step you typically don't write. The v to the 4th gets raised to the negative 4th power. And then we'll move on over here. See how the 4 is going to be raised to the 2nd power. U to the negative 2 is going to get raised to the 2nd power, and v to the 3rd is going to get raised to the 2nd power. Okay, then we'll go on to the denominator and do the same thing. So it's really just applying that power of a product rule. So the 7 gets raised to the negative 2. U to the 2nd, put it in parentheses, raised to the negative 2. V to the negative 3rd gets raised to the negative 2 power, okay? And really, the step that you see right now, you actually don't write that step. The step that you actually write is once you notice that when you're raising u to the 2nd to the negative 4th power, see how those parentheses, that parenthesis is between the exponents? Okay, so what we have here is that u to the 2nd that's being raised to the negative 4th power. So this is the power rule. And these right here actually are going to get multiplied. Now don't make that mistake and think that you're going to multiply 7 times negative 4 and say negative 28. See, this had the base was that u. So the exponents get multiplied. 7 is not an exponent. So don't multiply those and say negative 28. So really, this step that you see right now, I'm going to cross out in a minute. You really should do what we did, but you should write the result of it. You should say 7 to the negative 4. That would be u to the negative 8. So you'll just say u to the 2nd raised to the negative 4th power would be u to the negative 8. Then v to the negative 16. Okay, because you got a power being raised to a power. Those exponents get multiplied. Okay. Now the 4 and the 2 don't get multiplied. That's not an exponent, so that's just going to be a 4 to the 2nd power. The u will be to the negative 4th power, and v will be to the 6th power. And see, I would do it from here to here by just writing the result. U to the negative 2 raised to the 2nd power, I would write the result of that as u to the negative 4th. Okay, and then down here I would have 7 to the negative 2, u, I would say u to the 2nd raised to the negative 2 would give me to the negative 4th, and then v to the positive 6. But since this is the first one we're doing, I needed you to really see why we're using that multiplying right here. It's because that parentheses separates the exponents. You have a power raised to a power, so those exponents get multiplied, okay? But what you really should do is not write that step. Just apply the exponent to everything, okay, and get to here. So that's your first step. All right, now there's a lot of directions you could take, but I'm sharing with you the absolute best way to do it. And I'm usually not that opinionated. I usually don't mind you doing it a bunch of ways, but the way I'm showing you is going to make it a little less complicated, okay? All right, at this point, what I want you to do is get rid of the negative exponents, okay? So there's understood times in between all of these guys. So we're just going to wind up drawing the fraction bar. And then if we have a negative exponent, we're going to wind up thinking about how that negative exponent means 1 over. And so that means it gets moved to the other side of the fraction bar. So like 7 to the negative 4 becomes 1 over 7 to the 4th. Okay. U to the negative 8 becomes 1 over u to the 8. So see how I'm moving it to the denominator. V to the negative 16 would be 1 over v to the positive 16. All right, but now when I get to the 4 to the second, see how that was a positive exponent? It stays on top. But this one's a negative, so it's going to be 1 over u to the 4th in the denominator. See how the 6 is a positive exponent, so it's going to stay on top and be v to the 6th, still on top. So then I usually just kind of double check that I've done each of these items, that I haven't left one out. Okay, so I've taken care of all of those. Now watch what happens down here. So here we have a negative exponent, but it's on the bottom. And I can prove to you why this happens. But if you have a negative exponent, it does mean to take the reciprocal, but the effect it would have if it's starting on the bottom is that it would move up to the top and become 7 to the second power. U to the negative 4, negative exponent, it has to move, and it would become u to the 4th. But then v to the 6th power, that's going to stay, and see where it is? It's in the denominator, so it stays in the denominator. Okay? All right, so that's really the second step, is get rid of the negative exponents. Okay? Now, what I do at this point is I simplify the top part, get it kind of combined and looking good, what I can, and then I do the same on the bottom. Okay. I don't work out the numerical part though. I wait a little bit on that. But I do put like the 4 to the second and the 7 to the second, move those kind of in front. I usually put my variables in alphabetical order. And if there had been more than one thing with a u in it on top, I could have put them together. There just wasn't. But like in the denominator, see how I have that 7 to the 4th? But then see how there's a u to the 8th and a u to the 4th? Now, I don't want you memorizing the rules. What I want you picturing, I don't want you actually having to write it, but I want you to picture, well, that's going to be 1, 2, 3, 4, 5, 6, 7, 8 of them. Here's 4 more of them. They're all getting multiplied. Can you see why that would be u to the 12th? Because you have a string of 8 u's multiplied together and then a string of 4 u's multiplied together. So you have 12 u's multiplied together in that denominator. Then go back and think about the v's. Don't you have 16 v's multiplied by 6 more v's? Wouldn't that give you a total of 22 v's? Yes, the shortcut's just 16 plus 6, but I don't even think about that. I just think about having 16 v's and then 6 more of them, and that would get me 22 of them. Okay. And then one more step and we're done. Now what we need to do is see if there's any common factors that we could cancel out. Now please listen carefully on how to approach this. Let's do the variable part first. Okay, what I want you imagining, I don't want you just memorizing the rule and subtracting exponents and then reintroducing negative exponents. Here's what I want you to think. Don't you have 6 v's on top? On the bottom, you have 22 of them, right? You have a whole bunch, 22 of them. All right, what I want you thinking is I have 6 v's on top and I have 22 v's on the bottom. So I'm going to be able to knock out 6 of them. If you knock out 6 from the 22, aren't you going to have 16 of them left? That's how I want you to think about it. I don't want you getting that negative 16 exponent. I want you thinking this. I'm going to have 16 v's left in the denominator. Okay. Now look at the u's. I want you thinking about how here you have 4 u's. Here you have 12 of them, right? You got a whole bunch of them. There'd be 12. I'm not going to do them all. So can't you knock out 4 of them? And if you knock out 4 of them, aren't you going to have 8 left? And look at how 12 is bigger. Aren't those 8 that are left going to be down here? Okay. So what we're doing in this last step is we're looking to cancel out common factors from the top and bottom. So I'm knocking out the 6 V's here with 6 of the V's in the denominator. And because the denominator had the bigger number, the leftovers were in the denominator. Okay. Now we're going to move to the numbers. And, you could have worked all that out on the calculator, but we can do it the same way. Isn't 7 squared just 7 times 7? And then here we have 4 7s. So can't we knock out 2 of them? So that means we're going to have 7 times 7, which is 49 left in the denominator. That would have been knocked out. Those 7 squared would have been gone, right? We replaced it with 7 times 7. 7 to the 4th was 4 7s, and then we knocked out 2 of them, right? So all we have left in terms of 7s is 2 of them multiplied together. That's the 49. And then see up here, we still have the 4 squared. That's 4 times 4. So that would be 16. Okay? And there you have it. That's your final answer. So I wanted to do a really tough one so that you would see the 4 steps involved if you have a lot of stuff going on in a problem. Okay, so let's go back and kind of annotate what the steps are. You really don't show this step. You just do it. I just needed you to see why the shortcut would be to multiply, because you ultimately have a power being raised to a power. So as you clear the parentheses out, you're going to be multiplying the exponents. And then just be careful, the 7 and the 4 that you see, those are not exponents. Those are really the base, okay? So that first step is getting rid of the parentheses, okay? I'll just say that, get rid of the parentheses. And that's the one where you multiply the exponents, don't you? Okay. All right, the next step that you're going to do, the second step here, this is the one where we get rid of the negative exponents. You do that by moving to the other side of the fraction bar and make the exponent positive. Right? So mainly I want you just remembering to get rid of the negative exponents, but I'm just reminding you, because it means 1 over, it means to take the reciprocal. If it's on top, you would do 1 over 7 to the 4th and it would move down to the bottom. If it's on the bottom, when you do 1 over 7 to the 2nd, ultimately it winds up being on top. So the big idea is you can just move it to the other side of the fraction bar to change the sign. Okay? All right, the next thing you're going to do is you're going to work on simplifying the numerator and the denominator. Simplify each. Simplify the numerator and denominator. Kind of simplify them separately. Okay, so you're going to add the exponents. Okay, when you have, like we did here, when you have 2 expressions that have the same base, you're going to add the exponents. Okay, I'll just leave it at that. All right, and then the last step is to look at canceling out any common factors from the top and bottom. Hold on, it's trying to save. Takes a while because I'm in my office. It's not very quick. Okay. So frustrating. When you're doing this in the office, I'm on a really slow internet. And so it's not letting me move on because it's in the middle of an auto save. And we were to the point where I just wanted to summarize the last step. Okay, let's see if I can get it just to move on. Yeah, okay. All right, so finally, so the last step we did to go from here to here, okay, so that simplify the numerator, the denominator, that was this step, okay. Now what we're going to do is we're going to cancel out the common factors on the top and the bottom. And you basically subtract your exponents, but I need you to be careful. I don't want you to introduce negative exponents. So the way I want you to think about it is that I can subtract 6 from 22 and get 16. And because the larger number, the exponent with the larger number is in the denominator, that's why I have a 16 in the denominator. And then I can subtract 4 from 12 to get 8, and it would be a u to the 8th in the denominator. So no matter how hard the problem is, this is kind of the steps I'm going to do. First thing I'm going to do is get rid of parentheses. So when I get rid of the parentheses, to do that, you typically are going to be multiplying exponents because you're going to have a power being raised to a power. And you ought to go from this first problem to this step right here. Then at this point, you get rid of your negative exponents by moving things to the other side of the fraction bar. So that's all I did going from here to here. Is moved, if it had a negative exponent, I moved it to the other side and made the exponent positive. Then the next step I did was to look for things that had the same base, like the u to the 8th and the u to the 4th. And I didn't go across the fraction bar yet. I just simplified the denominator and simplified the numerator separately. Okay, so they had the same base, and so I pictured 8 u's and 4 more u's giving me 12 u's, okay? And did the same for the v's. And then the last step was looking at how there's a u to the 4th on top and a u to the 12th on the bottom. And so things that have the same base on top and bottom, I'm going to be able to cancel out the common factors. And so subtraction is involved, but what you're going to wind up doing is noting that the bigger number exponent determines where those leftovers are located. And then this is your final answer. So it's not that bad. It's really just 4 steps. And this is the hardest problem you could have in reality, okay? All right, so let me stop this and I'll get it posted for you.